So we did subnetting. We divided single class C network, which is 192.168.1.0, into 4 different subnets like this. Now 4 different subnets, how we did that? We did it by enabling the 0 host bits. Remember, these are the host bits. So we enable these host bits to 1 to get 4 networks. Like for getting the 4 networks, we need to enable 2 bits. You can see here, when you enable 2 bits, you will get 4 networks. So I enable those 2 bits here from the subnet mask to get 4 networks. And when we get the 4 networks, we remains with the 6 zeros, and when we get 6 zeros, that means we get 64 hosts. How? Because 2 raised to 6 means 64. So after enabling this, we get 64 bits, 64 hosts. Yeah, that means we get 4 networks. So we divided this 256 into 4 parts, and each part has the IP of a block of 64. So the block is what we get, 4 blocks we can say, and each block size is what, 64. And if you try to assign this IP to machine, then what, with the IP address we will not use the subnet mask. This is the default one. We will use this subnet mask. So when you assign the IPs like this, like for this department, I am assigning the IPs from the first IP, which is 192.168.1.0, to adding 63 in the block, it will go up to 192.168.1.63, not 64, because I am using 0 also. And this is the first IP for the block, so it is considered as a network IP. We can't use it on any machine. And this is the last IP of the block. That means it is a broadcast IP. We can't use it on any machine. So whatever the IP we can use is it is in between this. That means 192.168.1.1 to 192.168.1.62, and total IPs we are having here 64 for one block. And when I assign here in this block any IP, what I will do, I will not use the default subnet mask. I will use this subnetted mask, which is 255.255.255.192. And when I use this subnet mask, this subnetted mask for the machine, that machine will understand that we are having 4 different subnets. And what IP is this? Like if I use this IP, then machine will know that this IP belongs to the first subnet of this subnetting, this 4 subnets. If I assign this IP to any machine, so machine will understand with this IP, with this subnet mask, machine knows that this IP belongs to the third subnet of this network, and this IP is the network IP of third subnet, and this IP is the broadcast IP of the third subnet. Same as this is for the second subnet, and this is for the first subnet, and this IPs normal machine will not take it, because now they are considered as a network and broadcast. And that means we lose these extra IPs. If you don't have any subnetting, that means only this first IP is a network IP and the last IP is a broadcast IP. So we lose only 2 IPs from this 256 IPs. But when you divide it into networks, so for each network, each subnetwork, you lose network and broadcast, 2 IPs. Now I'll give you example of this by assigning the IP to machine. Now what I'm going to do here, I'm going to use one software to give you an example of this. Is this packet tracer. This is Cisco packet tracer provided by Cisco to do the all configuration of CCNA ICND1 and ICND2. So if you want to do practice of anything related to CCNA level, then you can do it here. Now for doing it, you have all the things available here. Thus you have routers. You can see here it is a routers, and when you click on it, you can see different models of routers here. Then you click on this is switch, and you have different models of switches here. Then when you click here, it is hubs, and you have different models of hubs. Then you have wireless devices also available. Then you have different type of connections here. These are different type of connections we have available. Then also we have end devices. Now end devices, that means the nodes can be a normal computer, laptop, server, or these other devices like telephone, TV, and also we can use IP devices also, IP phone also. Then you have some security devices available also, only one. You have WAN emulation, WAN clouds are also available. You have custom made devices, that means these devices are not configured, you have to configure it with the different ports and all that. Then you have this multi-user connection also. So you have different options available here which you can use to work on or to do the practice to the CCNA level, ICND1 or ICND2. So you can do all the practice here. It is very good and very easy to use software, and also it is very graphical, very graphical, like you can see what you are doing. Now only the problem is it can do only till, you can do it only till CCNA level. If you want to go in advanced level, then those commands actually not work here. So those options are not available here. It is only related till the CCNA level. You can do all the practice here in this software. So we did this subnetting, and I want to show you how it works on real machines, and how they are divided into different subnets, and how they are not able to communicate when they are in different subnets. And when you want to try to these IPs on the machine, how they will not accept it. So we have this software where we have all the devices like router, switches, normal machine, and all that. Now for this reason, for this thing to see this thing, what we need, I need four machines. Now four machines, that means I have this here, end devices. I click on it, and this is the PC I have. So I click on it and drag it onto the scene. PC1, PC2, PC3, now PC4. So I have these four PCs here. Now why I'm taking four pieces? So that I can divide them into four subnets. So now I have these four PCs. Now what I do, for communicating to each other, these four PCs should communicate to each other. So for that, okay, I have one option to zoom. So what I will do, I will use one switch. I can use any switch from here. So here is my switch. Now what I will do here, I will connect these four machines to this single switch. So for that I will go to the connections, and from here you can see this is automatically connection. This connection is for the console cable. Console cable is the rollover cable. This is a straight cable. This is crossover cable. This is fiber cable. This is phone cable, coaxial cable, serial cable, and octal cable. Now for connecting these different devices like switch to PC, what we need straight cables. So I click on this straight cable here, and then I click on the switch. So I have these ports here in the switch. So I select port number 1. Remember, I am not selecting console cable. I am selecting Ethernet. First Ethernet 1, and this is the cable. Then I go on to select this machine, click on it, and I select this fast Ethernet of that PC. One cable is connected. Now again I will select straight cable, switch, port number 2 to this machine. then again 3, and then again this. Then again I will click on it again, now 4, and now this port. Now you can see this green light here, that means the port is active, and when you see not green line, that means the port is not active. So actually when you connect the port to switch, it will take some time to be active, and why we will see. So now it is, these two ports are active, these two ports are getting active, this one will active last. So now they will get active. Now what I will do, I will assign these IPs to these machines. Now remember, I'm going to assign these IPs. I will assign the IP of those 4 different subnets we have. So we have these 4 different subnets. Now they are not subnetted, they are in single network. So I will go with this. So this IP I will assign to one machine. Then this IP I will assign to another machine. This IP I will assign to a third machine, and fourth machine I will assign this IP. Let's see that. So for configuring the machine IP, we click on it, and here we have the physical view where you can see the machine physically, and this is the configurations. This is the desktop. Now this is the desktop of the machine. Now here what we have IP configuration, we have dial-up, terminal, we have terminal also. We have command line interface where we can run some commands. We have a browser also. We can use browser also. We have wireless network option also. We have VPN, traffic, MIB browsers, Cisco IP communicator. We have firewall options are also available. Now I want to assign IP to this machine. So I will click on this IP configuration. Now here I will assign the IP address. You can see we have option to use DSCP or static. DSCP means dynamic automatic IP, and this means what? Normal IP. Now remember, if you put it onto DSCP and if the DSCP server is not available, then what happened here? You can see it is requesting the IP and it is not getting the DSCP server. So what it did here, it used this APIPA IP. Remember APIPA, automatic private IP address. So DSCP is failed, so it is using APIPA. And what IP it is using? It is using the range from 169.254 0.0 to 169.254.255.255. So it could use any IP in between. So this machine is using 106.180. Now I want to assign manually. I don't have DSCP. So I go on static, and even you can select IPv6 also, but we will see that later. So this is first machine. So I will assign this IP 192.168.1.1, and when I press tab, you can see automatically it selected the subnet mask. The subnet mask is what? The default subnet mask. So when you assign IP to any machine, it will select the subnet mask automatically. Now I am not changing the subnet mask. I will leave it on default. And we assume like we are not doing the subnetting. Then I will go to the next machine, desktop, IP, and for this machine, I will assign the IP which is from the next subnet. And that is what? This one, 65. So I will assign what? 192.168.1.65. Now again, I'm using default subnet mask. That means no subnetting. Now for this machine, what IP I will assign here? I will assign this 129 from third subnet. So 192.168 168.1.129, and again I am not using subnetting. Now this fourth machine, I will assign this IP 193 from the fourth subnet. So I click on it, desktop IP 192.168.1.193. Now I'm not using subnetting. Now if I try to check that they can communicate to each other or not, because they are connected into same network, they are using the same network, they are not having any subnetwork, so they can communicate. So if I try to check, so I will select the first machine. I can check any from any other machine. I will go to command prompt now, and now we know how to check. For checking it, we use ping command, and this one is looking very small. The text is looking very small. So what we can do, we can go to options, preference, and we can go to increase the font. For the CLI, I will say 12. For header also I will put it 12. Let's see, apply. Okay, go back again and command prompt. Now the text is a little big. So from this first machine, I will try to ping every machine. Ping 192.168.1.1. Now this 1.1 is the IP of itself. It is connected, it is getting the reply. So it is getting the reply. Now I will try to ping the next machine. Now this next machine IP is 65. And you can see it is getting the reply from that machine also. Now why they are getting the reply? Why they are connected? Because they are not in different subnets. Remember, they are using default subnet mask. Now I will try to connect the third machine, 129. This one is also getting the reply because they are in same subnet. Now I will try the last machine, 193. And this one is also sending the reply because they are all in same network. Now I will do the subnetting. That means what I will do? I will do simple. I will just change the subnet mask. I will change the subnet mask default to this 192. So I will go again and go to IP address. Remember, if you try to give the network address, like if I try to give 0, it will not take. It says that invalid IP address for subnet mask because this is network address. If I give this 192.168.255 again, you can't give this because it is not valid. It is a broadcast address. So you have to give any IP from in the middle of that network and broadcast. Now when it was the default subnet mask, it was like that. Now I'm changing it into 192. So what I did here, 255.255.255.192. Now when I give 192 to this machine, then what this machine now knows, that this machine is in subnet wing, it is subnetting there, and this is the machine which is in first subnet. Then I will change this also, 0 to 192. This one also I'm not changing IP, the IPs are same, I'm only changing the subnet mask, 192. Now after changing the subnet mask, these all four machine now knows that they are in different subnets. They can only communicate within their subnets, but they cannot communicate without outside of their subnet. So if I try to again ping it from this machine, first machine, I go to command prompt and You saw it was pinging last time, but now what? If I try to ping first myself, it is pinging because I belong to my own network. Now I will try to ping the next machine 65, and now it is not getting a reply. Now why it is not getting a reply from the second machine? Because now the second machine is in different subnet, because now we did the subnetting. We did the subnetting like we have calculated on that paper. So it is not getting reply. If I try to ping from the third machine, it will also not reply because it is in third subnet and it is a different subnet, it cannot ping. No reply. And same as the fourth machine will also not reply because that one also considered as a different subnet. Now if they are having an IP within the subnet, they can ping, but if they are in different subnets, they will not able to ping. No reply. So because these IPs now belongs to different subnets, so they can ping within the subnet. Like if I can have two machines with this IP and any of the IP between this and this, they can ping. Like for example, I will change this machine IP to 60. Now it belongs to same subnet. Now if I try to ping this IP, 60, now we are getting the reply because now it is in the same subnet. But if it is in a different subnet, it cannot ping. They are considered as a different subnets. So this is how the subnetting works. So when you don't do the subnetting, they will remain in a same network. They can communicate to each other. But when you do the subnetting, they will be divided into different subnetworks and they will not able to communicate. And how they do know that? Because of this subnet mask, because this subnet mask define like what is the network part and what is the host part. And if we want to do the communication between these different subnetworks or any other networks, we need router. That means we have to connect the router to this network, and then we can configure the router to communicate between these two or four or different networks. Now this is what simple subnetting. Now the next thing we will see is VLSM. So next thing what we are going to see is VLSM. Now what is VLSM? Now take a scenario here. We have a same scenario, like we are having four different department, and for these four different department we need to create a four different subnets, and we are having a class C IP network. We have a one class C network, same as what we have previously, but there is a difference here. There is a difference here that in one department, let's say I need 120 IPs. That means I have almost 120 machines there. Then for the other department, I need only 10 machines. Then for the other department, I need 30 machines. And for this department, I need 60 machines. 60 machines, that means 60 IPs. Now, what is the total of these IPs? The total is like 120, 130, 160, and 160 and 60, 220. So the total is 220. That means total IPs I need is 220 IPs. Now I have a network. So I have a network of what? So I have a network of 192. 192.168.1.0. Same. Or let's just change something like, okay, not 192, 1.0, 10.0. That means I have this network and this is the default CIDR value, that is default subnet mask. Or let's say I will add the subnet mask here instead of using this CIDR value. This is my default subnet mask. So this is what without subnetting. Now what I am having here, so I am having total host is 256. So total host I am having 256, and what I required here, how many hosts I required here. So I did calculated here like 10, 120, 130, 130, 130, 160 and 160 and this 60, it is 220. So I need what? 220 IPs, but total IPs I have 160. Now what I do now? I can do easily, because whatever the IP I need, this is what host 256. That means I have total host 256 I have, and what I need here, I need host or I can say needed hosts is 220, and we know that this is less than what we need. So that means what? It can be done. That means we can do the subnetting here. Now if I try to do this, so we know that for the network we need enable bits, for the host we need disable bits. So let's say this will be the subnet mask. This is my default subnet mask. Now that means if I convert it into binaries, so 11114567 dot 1234567 dot 1234567 dot 1234567. This is the default subnet mask we have. Now this is the default. I cannot change this one. So I can't change this, but I can change any of these bits. I can use the host bits. Now we need 4 networks. Now 4 networks, that means we know that for 4 networks what we need is enable bits. For networks we need enable bits. Now how many enable bits we need, it depends on what? How many networks we need, but we can't change this default one. So what we can change is what? This zeros. Now if we see the table here, that if I need 4 networks, I need 2 enable bits, because the enable bit means network. So if I enable 2 bits here. So I remove these 2 zeros and add 2 ones. So I will get what? I will get 4 networks. Now, what is the problem here? I will get network which is 4. Now the problem is this, the host for each network. Now for each network, how much host I will get? I will get the host 6 zeros. That means if you see the table, it is same as the previous one. 6, 2 raised to 6, you will get 64. Now 64 means I will get a 64 host in every block. So we get 4 blocks and in every block we get 64 IPs. Now what is the problem here? The problem is what? 64 is enough for this department because it is only 60 machines. 64 is enough for this one also because it is only 30 machines. 64 is enough for this one also. It is only having a 10 machines. But 64 is not enough for this. It is less than 64. 64 is less. It needs 120 IPs. It needs 120 IPs to be in a subnet. Now what is the problem? I am having only 64. So it can do well work with these 3 departments, but this department it will not work. Now for this department, if I feel like this department, like it is needed 120 IPs, that means zeros. So how many zeros I need to get this 120? Let's check the table again. So if you check the table, so 120 means 16, 32, 64. So 120 is here. That means it is in between this 64 and 128. So if I go 6 zeros, I will get 64. And if I go 7 zeros, I will get 128. Now 128 is more than 120 and it will be enough. That means I need 7 zeros. So I need 7 zeros to get 128 host. And 128 host is enough for 128 machines. Now when I use 7 zeros, that means this is 1, 2, 3, 4, 5, 6. So I change this 1 into 0. Now I have 7 zeros. 1, 2, 3, 4, 5, 6, 7. Now 7 zeros, that means I will get host 120. But how many network I get now? I get only one enable bit. And that means I will get 2 raised to 1 is 2. Now what is the problem here again? Now the IP is enough for this department, but now we remain with only 2 departments. That means I can use IP here and I can use the rest of the IP here because I have only 2 blocks. But what about these 2 blocks? These 2 blocks will remain as it is. Now we need what? Another network for these 2 blocks. So it is not fitting into these 4 blocks. But still we see here that we have total 256 IP and what I need is only 120, but still it is not properly fitting because of this unusual host we have. Like somewhere we have 120 and in some block we have only 10. It is very much difference. So it is what, if I use normal subnetting, if I use 60 blocks, if I use 2 networks bits and 6 host bits and we get 64, so we are wasting IPs here. 64 is enough for 60, but if I use 64 here, it is wasting the IPs. More than a half IPs are wasting here, and the here what, it is wasting more than a half or more than a half IP. It is wasting too much IPs here. and because these IPs are wasting here, we are not able to fulfill the requirement of this 120 unless we are having enough IPs, but still we can't fulfill the requirements. And that is what can happen in the real scenario. It is not like a book, like you will see always like this. These are like ideal host, and I have given this purposely, like one whole subnet, one department has 50, 30, 40 and 60 like this. I gave this purposely, I gave this identical thing, but it is not like in real environment. In real environment it can be having a more difference. Now in this case you can lost some IPs, you will lose some IPs if you do what, normal subnetting. Now in this scenario normal subnetting will not work. So in this scenario what we need to work and what we do and what it will work, it is called VLSM. Now it is called VLSM. Now this VLSM is nothing else, it is just a subnetting. It is nothing else but subnetting. It is only a subnetting, but this subnetting is done based on host, not on the network part. So this is also subnetting, but this subnetting based on host. Like we do the subnetting based on host requirement. We don't do the subnetting based on network requirement. We do the subnetting based on host requirement. So we do this based on host requirement. Now how we'll do this? So actually we do what? We do what? We do multiple time subnetting on the same network. That means we do the single subnetting, but now in this case what we will do, we will do multiple time of multiple subnetting, like we will do multiple time subnetting on the same subnet. And this is why we are doing it, to save our IPs. So what we do here, we do subnetting multiple time on same network. That means the network will be same, but we will do multiple time subnetting. That means first time we'll do subnet, then again we will do subnetting on the same network, then again we will do subnetting on the same network, and we will do it based on the host requirement. So how we'll do this? Very simple. So first what we will do, we will first we will do subnetting for large host requirement to minimum host requirement. That means we will do what? We will do the subnetting for the large host requirement first, and then we'll go on to do the requirement for minimum host. That means we'll do subnetting for large host to minimum host. That means first we will do subnetting for the large host and then minimum host, and to that we get we will get what? First we will get the large requirement host, and then what we will do, we will use normal subnetting, and we do what, we start assigning the IP. We will start assigning, I will say blocks of IPs like subnetworks on required subnets. Now when we assign these IPs to those blocks, then we will make sure that the IPs which we already use, we should not use it again, because we do the subnetting again and again, so we will get those IPs again, but we will not use it because those IPs are already in use. Now I will do it, then you will understand what I'm saying. So let's start with here. So first what I will do, I will not do this. Now first I'm going to do it for the large host. So first what I will do here, first I will get the large host. Now what is the large host here? So in this department we need 120, then we need 60, 30 and 10. So what is the large one? This is the big one, 120. So first I will do the subnetting for this 120. So first I will do subnetting for 120 host, or I can say large host requirements, that is in this case for 120 hosts. So I'm going to do it for this 120 host. So now what, I will start with this 120 host. Remember, hosts needed here is 120 in this department. We are not caring about network, we are only caring about hosts. So for this what I will do, I will change the subnet. So this is what the default subnet, and this is in binary. Now I want to change it based on the 128 host requirement. So what I need here is 128 host, and we know that if you need 120, you can check the table again. Now this table says that for 120 you can go up to 128. Now if you go one bit more, like 7 bits, you will get 128. If you get one less, you go 6, you will get 64, which is not enough. And if you go 28, if you go 8, one extra, then it is more than the requirement. So what we need is 120, and 120 can be fulfilled by this 128. And what I need, so I need 7 zeros here. So what I will do here, I will enable 7 zeros. Remember, when you are having zeros in subnet mask, it must be from left to right to left. So 1 2 3 4 5 6 7, and 7 means 7 zeros, that means we remains with one enable bit. Now one enable bit, that means I am having two networks, and in those two networks I will get what? 128 hosts. And that means what? I divided this 256 into two parts. We have total IP is what? 256. So I divided this 256 into two parts, two blocks, and each block has what? 128 IP. And I need only 120. Now, what will be the subnet mask for the department? Will be 255.255.255. Now I have one bit enable, and that is what? 128. Remember, these all bits means what? This is having a decimal value of 1, then 2, then 4, then 8, then 16, then 32, 64, 128. So if this bit is enabled, that means 128 bit is the bit of 128 value is enabled. So what I will get here is 128. So this is my subnetted mask for the subnet, and what I get here, I get two subnets, I get 128 host. Now if I want to assign the IP here, so it will start from what? So here the IPs will start from 192.168.10.0, which is the network IP, and it will end on 192.168.10. Remember, it is what? 128. So it will end on 127, one less than what we have, because we are counting 0 also, and that will be the broadcast IP. Now what is the valid IPs here? So the valid IPs will be 192.168.10.1 till 192.168.10.126. So these are the valid IPs. Now what I will do, I have two blocks here. Remember, I have two blocks, so I will assign one block. This is the one block, and I have actually two blocks, so I will show you those two blocks also. So the second block is what? 192.168.10.128. This is the network IP of the second block. And it is going up to 120. It is going up to 255, and this is what? The broadcast IP of the last, and the valid IP is what? 254, and here is 129. So this is the two blocks we have here in this subnetting. This is the first time I'm doing the subnetting for the network. So I created these two subnets, and these are the two subnets. Now what I will do here, I will assign this first subnet here in this department. So what I will do here, I will assign that one here. So it will start from 192.168.10.1, which is the network, 10.0, which is the network address, and then it will go up to 192.168.10.127, which will be the broadcast address, and all the addresses in the middle is the valid addresses. So all the addresses in middle will be the valid addresses. Now what is the subnet mask I will assign here in all the machines? When I give the IP to any machine here, so what subnet mask I will give here, I will not give 0, I will give the subnet mask which we have calculated here. So what we have calculated here is 128. So I will give that subnet mask here, and that is 128. Now we did a subnetting, we did use the one block. Now we created two blocks and we used one block. Remember, we used already this first block. Now we have only remaining this other blocks. That means we have remaining 128 IPs that we cannot use. Now what I will do, now I will do the subnetting for the next large subnet. Now what is the next large is here. After 120 we have this 60 here. So we are doing now subnetting for the 60. Now forget about the subnetting what you have done already. Don't remember it. You feel like you are doing fresh subnetting. And you will start from the again. Like now second I will do subnetting for second large host requirement, and that is what, that is 60 hosts in this case. So now I'm going to do it for the 60 host. Now again, remember how we do it. We do it by using the subnet mask and by enabling the host bits. So this is my default subnet mask 0, and that means what? That means this. That means what? This is the default subnet mask where this is the default bits which we can't use, and this is the host bits we can use. Now for getting the 60 hosts, how many zeros I need? So we can check the table again. Remember, this time I am checking for 60 hosts. So this is 2 hosts, 4, 8, 16, 32, 64 and 128. 120 is more, so I can go for 64 here. For 60 I can go for 64. And how many zeros I need? I need 6 zeros. I can see here by putting 6 zeros, because 0 means host. So if I put 6 zeros, I will get 64 host, and 64 host is enough for 60 machines. So what I do here, I will use 6 zeros, 1 2 3 4 5 6. Now remaining bits I will enable 1 2. So I will enable 2 bits because I need only 6 zeros. Now because we have 2 enable bits, so 2 raised to 2 we get 4 hosts, and in every host, because we have 6 zeros, we will get 64 hosts. 64 hosts in every block, and we get 4 blocks. Now 4 blocks, and each block have 64 IPs. Now what will be the subnet mask now? So now it is not default, it is changed here, and now we have 2 enable bits. Now these 2 enable bits are what? This first bit value is 128 and the second bit value is 64. So it is what? 128 plus 64, and that is 192. So we are getting this subnet mask, And now what that means, we get 4 blocks, and 4 blocks, each block has IP of 64. That means if you see, it will start from the here 0, which will be the network address, and then it will go up to 64, that means 63, that will be broadcast. Now I'm not adding the in the middle IPs. In middle IPs we know that this is what, or I will add it, let's add it, 192.168.10.1. It will start the valid IPs to 63, that will be the valid IPs. So this is what the first host, first subnet. So this will be the first block. Now the next block will be 192.168.10.64. It will start from here, which will be the network IP, and it will go up to, this will be the first valid IP. The last valid IP will be it is 128, so 126, because the last valid IP will be 192.168.10.127, because after 64, when you add one more 64, it will reach up to 128, but we can't use 128, so it will reach up to 127. Now this is second block, but we have what, 4 blocks, so we will have 2 more blocks. Let me create those blocks. 10.128. This will be the third block, which starts from 128 to 191, because it will be 192 minus 191, because we are using 0. So network address, broadcast address, and the valid addresses. Now the fourth and last block we will get is 192.168.192, which will be network address. So the valid address will be 192.168 and 193, till the last valid address will be 254, and the last IP for the subnet will be 250. .255, and that will be the broadcast address. So this is the 4 blocks we get now. Now remember, we have already did subnetting one time, and we divided it into 2 blocks, and we have already used 1 block. We have already assigned 1 block, and we have remaining only with the second block IPs. We are not saying like we are having the block, but we are having the IPs from 128 to 255. We have already assigned IP from 0 to 127. We have not available these IPs. Now when you do the subnetting for the second subnet, like for 60 host, you will do it the subnetting from the beginning, and you have did it, and you created 4 subnet, and each subnet has having 64 IPs. Now if you try to use these subnets, then you cannot use these 2 subnets, because why? because we have already used the IP from 0 to 127. These IPs we can't use, so these two subnets we can't use because we have already used it here. We have already used it here. Now what we have remaining is these two subnets. These two subnets, like these two blocks, and each block has 60 IPs. And we need only 60. So what I can do, I will use this third block here. I will use the third block here in this department. So third block, that means what? The starting IP is this 192.168.10.128 and the ending IP will be 192.168.10.191. I will not write these middle IPs, so I will do this on the third block. These two blocks is already used, so I cannot use it. So what I will do here, I will use it here. And that is what, from 10.128 10.128 to it will go up to 192.168 and dot, what was that, 191, and this will be the broadcast address. Now what subnet mask I will give here for this subnet, it will be 255.255.255. What we have calculated is this subnet mask. So I will not give 0 here, I will give what, 192. So all the machines I will assign IP here, I will use this subnet mask, and here when I assign IPs I will use this subnet mask. Now what I did here, we have already used these three subnets. Actually these two subnets we have already used when we did the subnetting first time here. Now when we did the subnetting second time for 60, we use this third block also. That means we used the IP till from 0 to 191 we have already used. Now what we have remaining is what, the 64 IPs remaining, like from 192 to 255 IPs we have already remaining now. Now what we will do, we need IP for these two different subnets, and we have 60 IPs, and what we need here, 30 and 10 is 40. So it is enough for us. Now if I use, because I have only one block, if I use here the remaining 30, remaining 60, so we'll not get it 10 for separate. So what I will do now, I will do the subnetting again for this 30, requirement of 30. So what I will do now, I will do subnetting for the third time. And now I will do subnetting for third large host requirement and that is 30 in this case. So that is 30 in this case. Now for 30 again I am doing the subnetting here. Now again we are having default subnet mask. In bits it is like this. Now what, for 30, how many zeros I need? Remember we are talking about host, so we need zeros. So how many zeros I need? I will check the table again. So for 30, so 30 is here. In after 16 we have 32 and then 64. So I need 30. So 30 can be available in this 32. So 32, in that I can use it for 30 host, because in this I can leave 2 IPs also for network and broadcast. And after minusing 2 IPs, still I will remain 30 IPs. And that is what I need. So exactly what I need is 5 zeros. So 5 zeros means I will get 30 host. So what I will do here, I am doing the subnetting again, and now I will use 5 zeros. That means 1 2 3 4 5, and remaining zeros I will enable and I will make them 1. So after disabling this, I will, after getting the 5 zeros, we will remain with 3 ones, 3 enable bits. Now 3 enable bits means 2 raised to 3, and that is 8. And 2 raised to 3, that means 8, and that means in every block we will get 32 IPs. So we get now 8 blocks, and in that 8 blocks we get 30 IPs. And what the subnet mask we get here? Now because we have enabled these 3 bits, remember the value of these 3 bits. The first value of the first value bit, the first bit value is 128, plus second bit value is 64, plus third bit value is 32. So when you combine all this, you will get 224. This is what you get, and this is what the subnet mask we have. So this subnet mask means we have 8 blocks and each block has 32 hosts. Now remember, we have already used IP till 191. We don't have IP remaining. We have IP remaining only from 192 to 255. Now what? If you convert this into blocks, now you have to create 8 blocks. Now I don't have a space to create 8 blocks. So what I will do, I will create after this 192, or let's say I will do it here, that 192.168 10.0, it will start from here, the first block, network, then it will go up to 192.168 10 dot. Now remember 32, so 32 means 31. This will be the broadcast address. The next block will be 192.168 10.32 will be the network address, and then it will go up to 192.168 10 dot. Now when you add more 32 into 32, it will become 64. That means 63, and that will be the broadcast address. This is second block. Third block will be 192.168 10.64 network, and it will go up to 192.168 10 dot. Now when you add more 32 into 64, you will reach up to 90. How much it is? For 96. That means 95. This is third block. Then the fourth block will be 96 to, it will go up to more 32. When you add more 32, it will reach up to 128. That means 127. Now this is what first, second, third, fourth. Now sixth block. It will start up to 128 the network, and it will go up to add 132, add 32 more here, so you will reach up to 50 60. It will reach up to what, 30 50 60. It will reach up to 60, that means 59. And that will be the broadcast IP. Next will be start from 160, and it will reach up to more 32. When you add, it will reach up to 192. That means 191. This will be, and then the fourth one will be from 192 up to more 32. Add, when you add more 32, it will reach us to 224. Then the last subnet will be 220. Oh, it will reach up to 223, because 224 minus 1, because we are using what, 0. So it will reach up to 192, 168, 10.255. And that is the 8 blocks we have. So this is the 8 blocks we have. Block 1, then block 2, then block 3, then block 4, then block 5, then block 6, block 7, and this is the block 8. Now you have to remember that we have already used IP from 0 to 191, which we cannot use. That means we cannot use all these blocks, all the 4 blocks. Then we cannot use this 5th block also. Then we cannot use this 6th block also. So which block we can use is only these 2 blocks. We can use this block, and also we can use this block. And in this block we have 32 IPs. In this block also we have 32 IPs. So what I will do here, I will use this block. The IP which is available is from 192 to 255. So I will use this block which has 32 IPs and which I need. So what I will do, I will use this 7th block here for this department where we required 30 IPs. 10.192 to, it will go up to 10.223 will be the broadcast IP. And what subnet mask I will use here is not default. It will be 224. That is what we have calculated. That is what we have calculated here. Now what we did here, now we have 2 blocks, this one and this one, and this one we have used here for this department. Now we remain only 1 department, and in that department we remain 10 machines, and we remain with the last block which is having 30 IPs. Now 30 IP is enough, and I can use these IPs here for this department. Now 30 we have, and what we need is what? 10. Now if I use 30 IPs here for this 10 machines, that means still I'm wasting what? Again 22 IPs I'm wasting here. So do I need to waste this 22 IP again? Or I can save these 22 IPs to use in future. I can do that if I do the subnetting again for this 10 host. So what I will do now, I will do again the subnetting for this 10 host. So now this time I will do the subnetting for the last and fourth subnet. Now I will do subnetting for fourth large host requirement, that is 10 host in this case. Now remember, you can go on like this until you reach and until you finish for all the departments. I'm having only 4 departments, so I'm going to do it only for 4, but as many as you have, you can go on to do that. Now again, I will do the subnetting from the beginning. Now remember, I'm starting it from the beginning. Now what I do here is what? How many zeros I need for 10. So let's check the table here. Now I need a 0. If I go for this 3 zeros, I will get 8, which is not enough. So if I go for 4, I will get 16. It is more than enough, like 10. I need only 10. But if I go 5, it will go for 30. No, I don't need this. I need only 10. So I can go for this 4 0 bits. So what I will do, I need only 4 0 bits. So what I will do here, 1 2 3 4. Remaining bits I will enable. So how many remainings I have? 1 2 3 4. So 4 enable, 4 disable. That means what? 2 raised to 4, 16 networks I will get, and in each network I will get 16 hosts. So 16 blocks, and each block will get 16 hosts. Now the subnet mask will also change. Now this time what? We have what? 128 plus 64 plus 32 plus 16. So we have these 4 bits enabled, and these 4 bits values are, first bit value is 128, then second is 64, third is 32, and fourth is 16. So what total value we will get here is 240. So this will be our subnet mask for this subnetting. Now I have 16 blocks. Now remember, I will not create all these 16 blocks. I have already used IP till this 223. So I will create after this 223. So from 0 till 23 we have already used. So we can say 224. This is what I have available, and it will go up to, now remember our block size is 16. So 16 means what? If I add 16 into 224, so what I will get here, 240. That means 239. This will be the broadcast address. Now what is the second subnet I have here? So 192.168.10.240, and then it will go up to when I add 16 here, so it will go up to 60 to 55, and that will be the end. Now that means what? I have remained only these two blocks. So actually I have 16 blocks, but I'm not creating those 16 blocks because we have already used those IPs. So I have remained with these two blocks only. That means we have before this block we have 14. We have already 14 blocks. This is the 15th block and this one is the 16th block. So we have not available those IPs till 20 to 23 we have already used. So we have remaining only these two blocks now. Now if I have remained these two blocks, so I can use this block here for our required host 10. So what I will do here, I will apply that 192.168.10.224, and it will go up to 239. So this is the block I used here. Now what will be the subnet mask for this block? So 255.255.255 now 240. Now I use this 15th block here out of those 16th block, and now still I have remained with this last 16 block, and also I have remained with 16 IP. That means I saved 16 IP which was not saving. Now how it works, that is important. How it works here. Remember the concept of subnetting. What and why we do the subnetting? We do the subnetting to separate these departments from each other. The basic reason for doing the subnetting is to separate these departments. Now separate these departments means what? They should communicate to each other. That means within the network, within the subnet, they should communicate. But outside the subnet, from the other subnets, they should not communicate. That is the basic reason for doing the subnetting. Now this is how we are achieving it here, by doing the subnetting multiple times. Now here in this 120 host department, all the machines here within this subnet, like from 0 to 127, with this subnet mask 128, all these machines here feels like they are having only two subnets and they are belong to the first subnet. Now other subnets they don't care about, they don't have to communicate to other subnets, so they don't care it, they don't communicate it. Now these machines, these 60 machines here with this range, like from 128 to 191, with this subnet mask, what they feel is what they are having four subnets. They are having four subnets, and this subnet is the third one. Like first two subnets are, they don't know where it is and they don't want to communicate to that subnets also. So they know that we are having four subnets and we belongs to the third subnet and we don't care about any other subnets. So they will do communicate to within their subnet. They will not do communication to other subnets and they don't need to. So what? They will be separated with others and still they will do the subnetting, they will do the communication within the network. These 30 machines here between these IPs 92, 192 to 223, with this subnet mask, what they feel, that they are having 8 subnets and they belongs to the 7th subnet of those 8 subnets. Now where is those 6 subnets from the beginning and where is the last 8 subnet? They don't care because they don't have to communicate with their subnets. They will communicate to within the subnet. They don't care about any other subnets, and that is what we want. Then this subnet, this last one, with these 10 machines with these IPs within 224 to 239, with this subnet mask, they feel they are having 16 subnets and they belongs to the 15th one. And where is the other subnets? They don't care. They don't do the communication. They will do the communication within their subnet. They don't care about any other subnet. And that is what we need, and that is what we did. So they will do communication within their network, but they will not do communication with any other network. So this is the achievement of subnetting which we want, and also we saved the IPs, and we did it by doing the subnetting multiple times. So there is no extra thing we did here. We just did the subnetting again and again, and just we didn't use the IP which is we already used. So this is what doing the subnetting based on host, so that you can save some IPs. One more thing, again, this could not be every time identical. That means every time it should not be identical, like these one department will have 120, then other will have 60, 30, 10, like this. It could be simple, it could be different. Like suppose apart from 60, if this department has requirement of 70, now what, we can't do this, because you know what, after 120 here I need 70 machines. Now 70 means what, if I try to do the subnetting here, so if you check the table here, so because you have already done 128, now if you go less than 128, and that is 60, so that is what, 64, and 64 is not enough for 70 machines. So you can't use this 60, you have to use 7 zeros, and 70 means 128. So there is no option. That means you can't do the subnetting again. You have to use the other subnet. That means when we did the subnetting first time for this 128, so we did what, we created two subnets of 128, 128. We use the one subnet here in this one. Now we remains only 128 IP. Now if I try to do the subnetting here in this 128, I have only one option. If I go to 6 zeros, I will get only 64, but the requirement is what, maybe it is 70. So 64 will not fit here, so I cannot do the subnetting. And then what, in this case I have to use this whole 128 block, the second block here in this department. Whether the IPs are wasting, but still I have to use it. And in this case, for these two departments, I have to get another network, another class C network. So basically sometime, or maybe it is not identical every time. So based on requirement, we do the subnetting, and it is called what, VLSM. Now one more thing, why we are calling it VLSM, because the VLSM means what, it means variable length subnet mask. So this VLSM means actually variable length subnet mask. Variable length subnet mask, that means if you see all these departments, they are having different subnet masks. This one is having 128, this one is having 140, 240, this one is 224, this one is 192. So because they are having different subnet mask, and that is why it is called variable length subnet mask. The normal subnetting which we did here, it is also called what? FLSM. This one is also called FLSM, and that means what? Fixed length subnet mask. Fixed length subnet mask, that means the subnet mask you can see in all the departments, they are same, they are not changing. So it is called fixed length subnet mask. And this one, where all the subnet mask of all the other subnets are different, so this is also called VLSM. And also we can say classless IP addresses or classless subnets. And when you have fixed, then it is called classful subnets. Classless, classful also. So this is what VLSM we have.